Okay, so let's actually take a look at some more test first stuff and sort of walk through it again. So for instance, right now we're getting all our tests to pass. This is the solution that I pulled up from our repository. Let's actually get rid of the entire solution. So one thing you're also going to want to do is, as you go through this, is to make sure that you fork your repo and make your changes. But here I'm going to get rid of everything that is causing this to pass and get it all to fail. And let's walk through it and see how we can go about it. Again, you want to just sort of eliminate a lot of the noise that you might have here. And let's go up here and see how many of these we can sort of get to pass in the next few minutes. So we've got this idea of concatenating the string. And we want to do this with a multiple number of arguments. So here we're passing these 3 arguments. We want it to basically concatenate anything that we end up passing to this function. So first thing we do is we go in here and we end up creating our method. Again, if we knew exactly how many parameters we were sending to this, we could write our function, but we don't. So what we can do here is we can actually loop over our arguments that are passed in here, and we could say for var I equals 0, I less than arguments dot length, I plus plus, and we can say results equals an empty array. We can actually just say even an empty string, and we could say results plus equals arguments I. This is one way to do it, and we could return our results. And if we go over here, we'll end up getting some of our tests to pass. Now, one way that it was shown on the solution, and this is fine too, is to actually turn our arguments into an array. So this we sort of mentioned before, and I'll just review it because I think that using the call method is kind of interesting. And the way that we're going to end up going about doing this is we're going to say array, and we're going to turn our arguments into an array. So how do we do that? We're going to say array.prototype, and we know that the slice method can create a new array. We've used it before. But what we're going to do here, we're going to say slice, and we're going to call it with the arguments. And so the context of this call is going to be the arguments that are passed in. And this will work if you have an array or if you have something that's array-like. So for instance, if I was to go in here, say console.log, ARR, and go back over here and pop this open, it would show me that this is an array. Notice the difference here. Console.log arguments. So arguments is showing up. It sure looks like an array, but it really isn't an array. It's an object that's got, it sort of shows up like an array, but it's an object with 3 keys, right? And those 3 keys have values. So it's actually, you could also sort of beat a dead horse a little bit, right? And again, these are just some things that will help you with the assessment. So these are arguments, and this is when I have my array, just to differentiate. So here's my arguments. Notice this shows me the values, but it doesn't say it's an array. I can even actually, so what's a method that an array has? If I said console.log, and I said, what's an array method? How about arguments.slice? Right, that's undefined, but console.log array.slice. This is going to be a function. So one way to, what I'm getting at here is that if you want to do this a little quicker, with a little bit less code, make it a little bit more elegant. We could return this array, and we can, the same way you could split an array, we could join it on an empty string. Our concat string should end up working. So let's take a look at that one. Let's actually go through and see if we can get another couple of tests to pass here. So this is our argument array one. And here we're going to be looking at higher ordered functions. So here's this sort of function that we're working with. Call this function, returns called value. Right? Higher order functions means a function can be called as an argument. And our function runner, when we end up passing in a function, right, we're expecting this to equal called value. So my function runner looks like it's doing nothing other than running the function. It's fine. It seems pretty easy here, right? So we'll go over here. Sometimes it takes a little while when you're looking at the spec to see what it's doing, but we can see that when we're calling this, we're actually getting a result that we're testing out immediately here. And here it looks like we are just returning my function call, right? I'm passing in a function, I'm calling it, I'm returning the value, basically returning, just wrapping that function call. And we can see that probably it's passing one of the tests, but not all of them here. I can actually see this, so here's my function runner, and if I end up calling the function runner, what it looks like it's doing here is that it's going to execute all the functions that I end up calling, and it looks like it is going to go and concatenate the results of all those function calls. So what that looks like that I can do is go over here and put in a result array. I can just do this as a string. It looks like I'm just dealing with a string. And I can loop over my arguments. And I could say for var I equals 0, I less than arguments dot length, I plus plus. And what I could do is say result plus equals, and here arguments I is going to be a function, and I'm going to call. So I'm passing in two functions, or three functions, or four functions. Let's get rid of this because this is going to work with a variable number of functions. I should be able to return result, and that should satisfy my result runner, which it looks like it does. So now let's move on to this next example here. And again, just sort of read what the tests are doing. You're not going to have to modify any of the tests. I mean, sometimes you'll comment them out to limit some noise, but we really haven't had to do that here. So here, again, looks like we're calling this makeAdder function, where we are passing in a value, right? So we're passing in adder of two function, and when we end up calling it with 5, we end up getting back 7. So here it looks like we're wrapping this make adder function where we're passing it a value, and it looks like we're going to get a function back that we're going to be able to basically create other functions with it. So again, the whole idea here is if you look at it, this is this idea of closure. This tells me that this is going to give me back a function, right? So if I just wanted to get that to, give me something, I wasn't quite sure where to go with this. I could go over here, say make adder, and just return function. And if I went back here, I would say, oh, great, you gave me back a function, but when I called it, it got back undefined. And just to sort of play around with this, let me just return foo. Right? So this makeAdder function is just returning a function, and when you call it, it's just going to return the value foo. And I can see that this is not quite what I want to get back. So I can see that when I call makeAdder, I'm passing in sort of a value that I'm going to be adding another value to. So I'm going to give this, I'm going to say num. I'm passing in some number. Believe it or not, once you end up passing this in, right, if this is passed in as a parameter, this value is going to be available in this inner function. That's what closure is, right? Basically, by putting in this inner function, you're creating closure. And if it wasn't for this function that you return, this number would sort of, my assumption is it would end up getting memory collected. But now when I call this function, I'm going to pass in some value. And I'm going to return value plus this number. And the reason why this value has a value is that it's being called with a value. And the reason why number has a value is that when I generated this function, number existed, and number is now available as closure. If it was defined out here, it's available from within this inner function. And this should end up passing some more tests here. Let's actually just get another one of these to pass. We'll move on to our once function. So if we look at this, we have this number here, and with closure, it's going to be available from within here. I'm passing in this function. And even though I end up I call increment multiple times, right? This function should only end up getting called once. So let's just take a look at that. We'll create our once. We're going to pass in a function. Again, if we just ended up returning the function, we'll end up getting this error that 2 is equal to 1. In other words, this ended up getting called twice, right? I basically wrapped it and called it twice. So again, we've seen this before. We have the ability to create closure. So I'm going to create this closure has run equals false. And I'm going to return a new function where I'm going to wrap my function in here. Okay? But what I'm going to do here, now keep in mind, if this inner function was supposed to return something, then we could return something, but that's just not really what's happening with this function. But what I'm going to do here is, again, if I ran this, I'm going to get the same error that I had before, which 2 is going to be equal to 1. So I just want to do a test here. Not if has run, but if it hasn't run, then run it, but just make sure, right, has run equals true, so it doesn't end up running twice, right? If it hasn't run, I'm going to set has run to true, and I'm going to call the function, and I should end up getting that object, that function to pass, or that test to pass. Let's take a look at one other one. Shared object, create object with closures. Okay. So shared object, 1 incrementer, 10's incrementer, get value. So we know that whatever object that we end up getting back, right, we're going to have these 3 properties here. And let's take a look and see how that ends up working here. We're going to get this to pass one at a time. Again, just getting the text to pass. we've got 1 incrementer, 10's incrementer, and get value. So this is going to be, copy and paste a little bit here. So we'll go up here. It doesn't look like we're passing anything to this function, but we are returning an object that has 3 functions, and those 3 functions are going to be 1 incrementer, 10's incrementer, and see if it's increment or okay. That. And we also have a third one, which is going to be get value. Let's see, this should allow some of our tests to pass here. So we've got our tests passing, but they're not necessarily totally passing here. Let's see what the closure part is. Okay, so what we want to do here is that we're going to have some value that's in here that we're going to end up storing. And we want to have this get value. So what we're going to do is we're basically going to have this object, and we're going to store some value in the object. So again, the whole idea here is that we want to end up creating this closure. And the way that the closure is going to work here is that we're going to have this, I sometimes give this an underscore here. And I'm going to start off with a value being 0. And when I call the 1 incrementer, I'll say value plus equals 1. And when I call the 10's incrementer, I'll say value plus equals 10. And when I call the get value, I'll return the value. And that's going to end up getting all of our tests to pass. So again, I sort of wanted to go through these solutions here, again, to sort of just show you that you should go through these things fairly tediously, read the specs. Again, you have a fair amount of time to do these, get one thing to pass at a time. And this is something we saw before, right? We did object.keys before. And the whole idea here in all of these is that you have the ability to create functions from other functions, right? And that's the whole idea of these second order functions. So hopefully that was helpful.